I'm Jez Everest. I work at British Geological Survey, and I've been working here at this glacier since about 1998, and since 2009 we've had an observatory site here at the glacier. Classic thinking suggests that glaciers go through periods of advance and retreat, and since we've been working here over the last 18 years, the rate of this change would normally have been considered not strange in the light of the last century. However, the last 7 years we've seen a speed of change and a rate of retreat and melting here at the site that is without precedent in historical times. So since 2009 we've been looking at the glacier in a lot more detail. We have systems on site here which look at the glacier dynamics, the rates of change in the landscape around the ice, in the hydrological and groundwater systems that operate beneath and around the glacier and within the wider catchment. So we're trying to look at the glacier's health and the state of health of the landscape around. Just like a patient in a hospital, we've effectively wired the glacier up and we observe it around the clock. We have many instruments here looking at real-time data acquisition. We're checking the weather conditions, temperature, humidity, wind speed. We measure the glacier movements. We look at the water flow from the glacier and the general water flowing in the entire catchment around the glacier. The research we're doing here is important because many communities around the world rely on glaciers for their drinking water supply and their power supply, and often for industrial usages as well. Iceland itself is reliant on a lot of hydroelectric power schemes, which quite a few of them are glacier fed. We obviously know that melting of ice sheets causes sea level change and flooding in low-lying areas. But what are the effects of smaller ice sheets, not just Greenland and Antarctica, those that are sited on terrestrial landmasses? What are the effects of their melting? We know that glaciers melt during the warmer months. That's not unusual. But we're starting to see worrying patterns now, particularly here in Iceland, where the glaciers are melting all year round. Our research is helping us to recognise symptoms of an unhealthy glacier. We're seeing and measuring early warning signs that a glacier, just like this one, is entering a period of rapid melting. The observatory we have here is a big team effort, not just from scientists from the UK, it includes scientists from Iceland as well, and we have visiting scientists from across the UK university spectrum. Our team from British Geological Survey includes, obviously, geologists, but we have hydrogeologists, seismologists, geophysicists, and obviously technical support as well. As I say, it's a big team effort. We're measuring the glacier's movement through GPS and laser scanning using an instrument like this. We record the weather from permanent stations on the glacier sides. We have remote cameras at several locations which record pictures at least 3 times a day, in some cases every hour. We have seismometers detecting and recording ice quakes and normal earthquakes and volcanic activity, particularly important here as we're sited on Europe's second largest volcano. Some of our scientists use radar equipment that look through the ice to the bed and actually see the internal structure of the glacier itself. Our hydrogeologists sample and analyse the flow and chemistry of groundwater, which is partly recharged by glacial meltwater. We have observations on the glacier surface, where we're positioning stakes to measure melting, and we observe and record the changing patterns left by the meltwater, the ice caves or moulins, and the meltwater channels on the glacier surface and within the glacier itself. It's a full and comprehensive survey, and we think it's probably a world first that combines such a wide range of sciences, instrumentation and observation, all at a single site. We'd call it whole system science if we were pushed to come up with a name. Looking at the glacial system as a whole has clear benefits, such as understanding how glacial structures control meltwater drainage, understanding how glacial melting affects landform development, and understanding the hydrology and water resources of the whole catchment, from the ice to the river to the groundwater. Scientists around the world are reporting rapid melting of ice, and if we thought it was part of a normal cycle, we wouldn't be so worried. But in historical terms, the speed of melting is quite alarming. What will this glacier look like in 10, 20, 30 years' time? Will it even be here? We're developing a better understanding of glacial systems, and we're starting to be able to recognise the signs of glacier health. But will all this be too late?
The first race test that we've done from this glacier. So we've chosen a moulin that's got a really good stream going into it with quite a lot of flow, and it goes down into quite a deep hole, so hopefully it will go into the main system quite quickly. We're about a kilometre away from the outlet point, and the dye we're going to put in is sodium chlorosine, which is a green fluorescent dye. I think we're ready to go.
Yeah.
So it'll probably look quite orange when I first put it in, and then it will very quickly go green. Ready?
Yep.
Yep. How's that?
That's awesome!
So awesome! So you can see that some of it's sticking to the sides. We'll see how long it takes for that to go down. And I bet you have to be really careful here now. These drugs don't get confused and have to sit behind the rocks down there. Just want to really go. Yeti pee.
Can you see down there, Lee? Can you see down there?
Yeah, more or less. It's hard to.
Yeah, don't get too close, mate.
You can see the